real sequences and series next. Still working on geometric progression, and that's GP. And so we'll also be considering the geometric mean, sum to infinity of geometric progression. Okay, so as before, I expect that you know all these definitions for what we have for the formula for a geometric progression. Its first term is common ratio and its first term A, right? And what the geometric series is and when we use them for the conditions you can see on the screen for its common ratio, right? What the geometric mean is where I'll be focusing on. So for a geometric mean, just like we saw for the arithmetic mean, we have three consecutive terms, x, y, and z, right? And it satisfies this formula here, y is equals to square root of x times z. Okay, so we also have the condition that if you have the finite geometric progression of this form, then we call the u2 or un to be geometric means between u1 and un. Okay, so u2 all the way to un minus 1. There's a comma here missing. Okay, right here. Okay, so you need to know these definitions. Okay, again, like we did earlier in the video for the arithmetic progression, you can pause the video and practice this solution. There are things, just do a revision because these are things you've done in secondary school. Same also for example 2. So example 3 will be my focus as done in the video for AP. So now we have to insert we have to insert two geometric means 2 between 1 and 8. So it means we have 1. We want to insert two geometric means, so we have u2, because this will be our u1, u2, u3, just two of them, my 2 between 1 and 8. So this will be 8. So that's why you see u1 is 1 here, and u4 is 8. So this is u1, this is u4. Okay, so we're inserting just these two between them. Okay, so let me clean the screen. So we're inserting these two geometric means between them, u2 and u3. Clearly our first term is a, which is 1, as you can see here, and our last term is 8. So u4 can be expressed in this form, recalling that the formula for a geometric progression is a times r raised to the power n minus 1, right? So wherever you see n, because our last term is the fourth term, you have 4 minus 1 where there's n here, right? Okay, and 8 is our last term, so that's why there's 8 here. So we have 8 equal to a r to the power 4 minus 1, right? Okay, so that's what you see on the screen. So we simplify further. If you simplify, we have that we know what a is, so this ar r to the power 4 minus 1. We know what a is. It is 1. That's why there's 1 times r to the power 3 here, because 4 minus 1 is going to give you 3, right? So if you have 8 to be equal to r to the power 3, you simply take the cube root of both sides, right? Or multiply by 1 over 3, the powers by 1 over 3. That's why there's 8 raised to the power 1 over 3 on this side, as you can see here. And that would be equal to r, right? So what's the cube root of 8? That's 2 times 2 times 2, right? So the answer is 2. So we found r to be equal to 2. So having found r, that helps us know how the progression increases or decreases, right? So we know what to either multiply or add to get, multiply or divide to get our next term. So what's the formula for u2? If we want to get u2 now, we have a, to get u2 and u3. We have a, we know it is 1. We have r, we have found it to be 2, right? So all just to substitute by solving for u2 and u3. So u2, wherever you see a and n and r, so that's what we have here. A is 1, r is 2, and we know it's 2, the power is 2 minus 1, right? So that's how we got this value here. Same also u3 is a times r to the power r minus 1, which is a times r to the power 2, and that would be 1 times r to the power 2, 1 times 2 to the power 2, which is just 4. So we find the two consecutive terms, which sorry, the two geometric means, which are 2 and 4. And that concludes the video. Thank you.